Hey folks, it's Svetlin from the Phoenix team here, and I'm going to show you how to create an effect of slime stretching out into thin strings of fluid. So, first off, I'm using a Phoenix 5.10 nightly from the 29th of June. So, let me start with creating the actual setup. So, I'm going to use two boxes moving away from one another like this, and the fluid is going to stretch between them. So I'm actually even going to copy this one once again and use this as the emitter. So I'm going to make it non-solid. I'm going to also make it not renderable, display it as a box like this. And here is where I'm going to create my liquid at the start, and then I'm going to animate this box to move away like this, for example. So we're going to have the fluid stretch between those two plates. I'm going to add the liquid simulator around those geometries right now. So maybe I could even use the adaptive grid. So I'm going to use the new Phoenix main window like this. I'm going to open it, and then I can dock different Phoenix rollouts inside it like this. So I'm going to dock the grid and the dynamics rollout. I'm going to make it narrower. And what else do I need? I need a source. So I'm going to pick the not renderable, non-solid box. I'm even going to rename the box to what? Box emitter, for example. And okay, so if I run the simulation right now, let's see what we get. So I have the liquid being created from the box at all times. It's got a lot of pressure, and at some point the upper plate exits the simulator. So okay, this is the very initial result that you'll get without tweaking anything. So this is far from what we need. So first off, I'm going to switch to volume brush mode, and this way liquid is going to be created only inside of this box. Now liquid is being created all the time throughout the simulation. So next thing I'm going to do is to animate this from 100% to 0. So it's going to emit for just the first frame of the simulation, and then it's going to stop emitting, and the liquid is going to eventually slide off. So you could see that even the movement of the upper plate entangles the liquid a little, it moves it up. So next I'm going to enable adaptive grid, so the simulation would expand, the grid would expand as liquid tries to exit it. Alright, so now you can see that the liquid is trying to spill out. Then I need to also take care of my scale. So this whole thing is 8 meters tall right now. So I'm going to decrease the scene scale. So in order not to touch anything in the scene, I'm just going to make the simulator think that the entire thing is just smaller. So I'm going to reduce the scene scale option right here. So now it's going to think that the simulator is initially like 1 meter tall, and it's going to expand. So now you can see that the liquid starts dripping out a lot faster because the scale is smaller. Next, I can enable viscosity so that we would have some stickiness. So I will raise it up a little just to see what's going on. Now we're going to have more viscous fluid. I might even increase the resolution just a little so that we have more particles. And in order for the viscosity to, okay, so you can see that here the liquid starts behaving more compact. In order to have a better viscosity effect, you would need to increase the steps per frame a little. So this way the liquid is going to, it's going to keep its shape much better. So 4 steps per frame might even be too much. You can see that increasing the steps per frame also slows the simulation down. So for example, if you use 4 steps per frame, the simulation is basically going to be 4 times slower than initially. But still you can see that the liquid tries to slide off of the bottom plate. So what we're still missing is to enable wetting, and this way we would be able to tell the liquid to stick to any of the geometries where these red wet map particles appear. So here the wet map is actually where the liquid touches the geometry. And when we also have sticky liquids, when we have viscosity, you can see that the liquid starts to stick, and now we're going in the right direction. So now you can also see that the adaptive grid starts kicking in, and yep, so now we have some liquid stuck to the upper plate and some liquid stuck to the bottom plate. You can also see that pieces of liquid are falling down, and yeah, we could also use this effect for example, like a chocolate bar with caramel filling where the chocolate bar is broken up. So, but still this doesn't quite look like what we need. I'm also going to enable the mesh. I will also expand the preview rollout and add it here. So if I enable the mesh, you can see that this is not really satisfying. So it looks quite chunky, it's not stretching out the way that we want. So first off, I'm still using a very low res grid, so we still have just 600,000 voxels initially, so anything below a few million is super ultra giga low res. So I'm going to increase the resolution, but in order to keep, now you can see that if I start the simulation right now, it's going to play out really much more slowly. So you can see here the steps are dialing up, 1, 2, 3, 4 steps, and you can really see that the simulation has slowed down a lot. So in order for me to be able to iterate faster, I'm just going to, oh, and I also see that my grid is it's unnecessarily deep. So I'm going to keep the voxel size, but I'm going to shrink the grid and just make it narrower in order to be able to have a faster simulation. Alright, so now we can see that even the viscosity is doing a very good job because most of the liquid is actually sticking to the upper plate. It's starting to stretch out in some thin strings, thin like fibers of wood, but it's still quite chunky. So if I enable the mesh, you can see that it's really, it's not really working smooth. So the most important thing one of the most important things in this setup is the surface tension. So I'm also going to add some surface tension right now. So for example, let me start with 1. So this control actually goes above 1. You can set it to higher values than that. And I'm going to keep the droplet formation to 0. So if this is 0, the surface tension is going to actually produce kind of the stringy effect that we're looking for. So if I start increasing the droplet formation option, then the surface tension is going to try to create round droplets of liquid. But in order to get those strings that we're looking for, I'm going to increase the surface tension like this, and you can see that we are starting to get the effect that we want. So first it's stretching up, then the liquid tries to slide down. So here the balance between the grid resolution and the viscosity is very important, because as you increase the grid resolution, the actual effect of the viscosity decreases. So if I need to create more particles and I would increase the grid resolution, then I would also need to increase the viscosity in order to compensate for this. Alright, so here is how how the simulation looks. Let me just play it. Okay, so we're starting to get there. I'm going to even increase the steps of frame a little more. I'm also going to increase the grid resolution. So let me stop the simulation. All right. And yeah, let's see. Let's see how this grid resolution works. Maybe this is going to take longer time to simulate. Okay, so since I also increased the grid resolution, I'm going to go back to 300,000 as the initial grid resolution, but using 8 steps per frame this way. So this way the simulation is going to be more precise, and the surface tension is going to have a better effect, so you'll be able to see it better. I think the viscosity could be about right. So if you want chunkier liquid that behaves more solid, you could still increase this, but in this case you're going to eventually start having some like hard pieces of liquid inside of this simulation, especially when it starts dripping down. You'll be able to see those chunkier pieces of liquid. So I think that we're getting a pretty good result. So you could see that the simulation right now is pretty symmetrical. So everything is kind of the same between the left and right of the simulation. So if you look at it from the side, again, it's pretty symmetrical. The liquid tries to bunch up in the middle of the simulator and just to have as little surface area as possible. So in order to make this more interesting, one thing that I could do is I could add some noise to the source, to the discharge of the liquid. So I could plug a noise texture here, but this way I would create more liquid in some places and less liquid in other places. Instead, I'm going to actually transfer the responsibility for creating the viscosity from the dynamics throughout. So I could even set this to 0, but you don't have to do this. So if I set some viscosity in the source, then it's going to override this. So this is why this is called default viscosity, because it's the viscosity that exists by default in the simulation. But if I tell the source to create a certain amount of viscosity, for example, like 0.4, then this is going to be taken over by the source. Alright, so perhaps in this case the viscosity is too low, so if I raise it up, you can see that it started sliding off of the upper plate. And actually, let me just even plug the noise texture right here, so we could adjust that. So I don't want the OSL map, I want the regular noise, like this. Edit. Alright, so where's my preview? Map 0, 1. Okay, nothing is working. Here it is. Okay, so I'm going to use world XYW. Let me XYZ. Let me see how this is going to look. I'm actually also going to I'm going to show the viscosity of the preview right here. So let me see if changing the default actually makes any difference. So okay, I see why my viscosity in the source is not taking any effect, because I am probably not exporting it to the liquid. Okay, so here it is. I need to enable particle viscosity. So this way, we're not going to have just a single value. So now I can really set this back to 0. We're not going to have just a single value for the viscosity throughout the simulator, but each particle is going to remember its own viscosity. And this way, each particle could have different viscosity. So I needed to enable this in the output throughout in order to make the simulation uh, do what I really want it to. Okay, so now you can see that we're getting some good stretching, and I'm also going to cover the particles based on their viscosity. So let me go back to the earlier frames of the simulation. So it looks to me like the noise here is kind of the right size. So if I shrink it too much, it might start becoming just, yeah, this random pattern, which really isn't going to make the simulation that interesting. It's just going to make it more grainy. So it was 3. If I make it like 6 or 7, then the actual size of the noise might become too large. But again, it's up to your preference. Depending on the scene and the effect that you want to get, you could set this to different values. So I guess that 6 might be too high, but let's see how it goes. If we manage to break the shape of the liquid in such a way that it's not symmetrical anymore, then this is the correct way to do it. Okay, so you can see that, yeah, it started creating some of these liquid fibers or liquid strings right here in the middle. So I guess this is working out. I'm just going to disable the auto reduction just in case, so that I would be able to see all the particles and not just some of them. Alright, and here you can see that the effect is starting to get more interesting. And in this case, I'm eventually going to restore the size of the grid to its fullest extent. Okay, so here's how it looks. Interestingly, all of these strings started sliding down into a single point in the middle. But yeah, this way the result is really more diverse than without the noise map. So okay, I could restore the resolution, just make it with a square base again, so kind of like this. Maybe just move it a little to the right. Okay, so that it covers the entire so that the entire bottom and top plate are inside of the grid initially. And I'm going to start the simulation, and now if I enable the mesh preview, I'm going to disable the particle preview. There are some things that we could do to the actual look of the mesh, because this is actually what is going to be rendered. So the mesh is going to be our liquid. So on one hand, it needs a good gooey material, like slimy material that is going to make it look nice, or for example like a caramel material. But also by default the mesh is not going to be that good for this kind of simulation. So you can see that here different cavities are starting to appear as it moves up. So now that I increased the size of the grid, you can see that the simulation is now taking more time. And once it starts stretching, then we would see the most important parts of the mesh that need to be addressed. So I could even just change the preview color to something like more toxic green, like this. Right, so since I'm going to use the render and grow out, I could also expand this so that I could deselect the simulator. I could move the Phoenix main window just out of the view entirely. Yeah, I could dock this one inside of 3ds Max. Now the idea of the Phoenix main window is that it's going to preserve this layout of all of the Phoenix rollouts that you've docked inside it when you save the scene. So next time that you open the scene, you could just keep the same layout. While if you just dock the Phoenix rollouts inside of 3ds Max, this is going to be lost between scenes. So if you set up your workspace in a way that you like it, you could use using the Phoenix main window, this is going to be saved in the scene file. So, okay, so here you can see a little drop of liquid. So in order to prevent those droplets from appearing, you could either increase the velocity, the viscosity. But now that we've transferred the viscosity to the source, it's actually going to be controlled from here. So you could even either increase the viscosity by changing the texture map. So now that it's used as a mask, I could even increase this one. So this is going to be the base viscosity, and also I could increase the surface tension a little. So I could, for example, make it 2. Let's see how this one behaves. So this one is quite, yeah, it's running quite a lot, so it's still dripping from the upper part. So what I wanted to show you before I run the maybe final simulation, I'm going to just enable the mesh smoothing here from the input rollout. So I'm going to just generally smooth the grid liquid channel. So you can see that if I smooth it like that, these strains here, they become thinner, and also the mesh becomes generally smoother. So now if I go back to the rendering rollout, which I popped up right here, I could change the isosurface level, making the mesh thicker or thinner. So you could also adjust it to your liking. So you could see that some of these dripping parts of liquid start to get lost. So by default it's 0.5, so this one should be enough for most cases. I could also enable the mesh smoothing, so I could add some smoothness like this. And again, in order to control the thickness of the mesh, I could also enable use liquid particles and then change the liquid particle size. So I could make it extremely thin like this, or I could make the liquid particles thicker. So if I rewind the simulation back, let's see, so now you could see that we have like more like droplets. So if I go too low on the particle size, these are going to just become like thin lines of mesh. So this might not be the result that you want. So maybe like something in the middle, just below the particle size. So now that I've changed the viscosity in the source and the surface tension strength, let's start the simulation one last time and see what is going to be the final result that we get. I'm even going to pause the video for a second, and then I'm going to go back showing you the final animation. Alright, so the simulation is just ending. Now we have about 100 frames of animation, so you could see that we have some of these thin strings of liquid running down. Some others have already been interrupted and have broken, and the liquid will be moving down. So if you want to make the liquid even more solid, you could increase the viscosity in the source even more. So let's see it in animation. So maybe uncheck real time and see how it behaves. So you could see that we have some interesting cavities here. Here the liquid starts breaking up. By the way, a very important factor that you might need to adapt to your own setup is the actual amount of liquid that you start with. So here you know that we are filling up this invisible box right here with liquid initially, so you might want to create more liquid or less liquid depending on your setup. So this is also going to make for a very different effect in the end. So for example, if you have too few liquid particles, the liquid is going to start breaking up much earlier, and is going to break up a lot. So if you want to have thicker strings of liquid running like this, you could increase the amount of liquid initially, And also, yeah, you could also play with the viscosity. You could see that here we are starting to get some interesting effect like this. So this is because of the noise texture in the source. You could also vary the actual noise inside the noise texture, so you could change the thresholds in order to make it more contrasty. But beware that if you make part of the liquid too having too low viscosity, they're going to be too runny, and yeah, it might not look that good. So perhaps beware that you shouldn't have any completely black parts of the texture, as they are going to zero the viscosity in some areas of the liquid. So I think that this was all, and thank you for watching, and see you next time.